All right, so we're going to start off here 3.1 with GCF only. So for GCF, we're looking for to take out the biggest number that the coefficients can divide by first, and then the smallest power of each variable if they all have it, if they all have that variable, okay? So number one here, I look at all these numbers, I think these all divide by 7. And then they don't all have an n, so I cannot take out an n, so I'm just going to take out the 7. And then I'm going to put a parentheses, and then I put inside, I'm going to divide each number by 7. So this becomes -5 n to the 5th. This one becomes -5 n to the 4th. 63 divided by 7, it would be 9 n to the 3rd, and then 10. All right, so same idea here on number 2. So I think these all end in 0, so they all divide by 10. And so I get 7a squared plus 30a minus 6, or plus 3a minus 6. And then on number 3, I see that these all end in 5 or 0, so I know that's divisible by 5. And then all these have an a, so I can take out the smallest power of a, which is 3, and then the smallest power of b, which is actually 1. And so if I take that out, I divide the coefficients. This is going to be 9. And then a to the 6th, and I take out a to the 3rd. We're really subtracting those exponents. That's going to be a to the 3rd. B to the 5th, if I take out a b, will be b to the 4th. And then the next one, 30 divided by 5 would be 6. And then a to the 7th over a to the 3rd would be a to the 4th. And then b to the 3rd divided by b would be b squared. And for the last one, 35 divided by 5 would be 7. And then we take away a to the 3rd is gone, and then the b is also gone, so that would just be left with a 7. So if you take out all of that variable, it is just gone. All right, and then last up here, number 4. So for this one, I think these all divide by 7. I can take out one x because they all have an x. They do not all have a y, so I cannot take out that. So left inside here, 35 divided by 7 is 5. And then the x divided by x goes away. 49 divided by 7 is 7. X to the 4th divided by x is x to the 3rd. And then that y is still there since I did not take out a y. All right, and then this one, the 7 is gone, so I'm not even going to write that one. You could write a 1 there if you wanted to, but since I have the variables, I don't really need it. X squared divided by x is just x, and then the y squared is going to stay there. All right, next up I'm going to do number 6. This is actually a little bit of review from 3.2 notes, which we did before. So for this one is a trinomial, and so I'm going to make an x here. We're going to do a times c up top, which is 9 times 4 would be 36, and then b on bottom would be -12. And we're going to think of two numbers that multiply to 36 and add to -12, which would be -6 and -6. So I use those to split up that middle term, and then we keep this first term and the last term. Oops, just a 4 there. And when we group them up, and I get 3x, I can take out a 3x here, which leaves me with 3x minus 2. I can take out a 2 out of these two, but since the third term is negative, I want to take out a -2, which will turn this to positive 3x minus 2. And so I actually get 3x minus 2 times 3x minus 2. Now, I'll tell you that normally, if you have the same thing twice like this, they're going to write that as 3x minus 2 squared. All right, next up, we're actually going to learn new factoring here, and so that is for binomials, so 2 terms. We're going to watch out for a difference of perfect squares. So we kind of need to know the perfect squares here, so I'm going to write them down over here. All right, so there are perfect squares there from 1 to 12. I think those are the main ones. So if we notice these in these binomials with these ones with 2 terms, then we have that here, and it's subtracting in the middle, so difference means subtracting. Then we can factor these with just 2 parentheses. And then what we do is we just take away the squareds. So if I take away the squared from b squared, it's just b. If I take away the squared from 9, it's just 3. And we do 1 plus and 1 minus. It does not matter the order. You can do the plus first and then the minus, or the other way around. Doesn't matter. Just need one of each, okay? All right, so then number 8 is kind of similar there. We're going to go ahead and skip number 7 here, but number 8, I see that 9 and 25 are perfect squares, and they are subtracting, so I can draw my two parentheses here. I could take away the squares here, so I get 3r, I get 5, I get 3r, I get 5, and just put 1 plus and 1 minus. All right, same thing for number 9. So I know these are perfect squares, so I got 5r and 2, 5r and 2 with 1 plus and 1 minus. Now number 10, these are not perfect squares, but I see I can do a GCF here, so I'm going to take out a 5x like we were doing at the top of this page. If I take out that 5x, I'm left with a x squared minus 4 in there, which then I can break down as x minus 2, x plus 2. So if you ever have a binomial that's not perfect squares, see if there's a GCF, and then try it out.